In Module 8, we're going to look at the other deployment options for your applications. So the containers, the Docker containers, and the virtual machines. Virtual machines are a virtualized machine, as they say. So when I run a virtual machine, I have a host that runs a hypervisor, and then each virtual machine contains an entire image of what would be on a physical machine. So it includes the operating system, all the middleware, runtime, and the application. A Docker container has a slightly different model. It runs on a host machine, but this time we make use of resources of that machine. So I don't run another virtualized instance of what would be a physical machine. I now have a series of layers where the containers will share some of the underlying resources. So Linux kernel provides a container service, but it allows you to isolate the processes, a collection of resources, and ensure that it can't see resources belonging to other containers. So with a container, I get an isolated set of resources, memory, processes that no other container can see. The advantage of using a container is they're much higher density. Because they all share the same underlying operating system image, and in some cases they can share the middleware images, then I can run a lot more containers on a single physical machine. Because containers don't need to start up the underlying operating system like a virtual machine has to do, they are very, very fast to start up. If you've noticed, when you scale a Bluemix application, the additional instances come online within a second or so. I don't have to wait for the operating system to boot up and then start the middleware. And containers are also portable. So I can take a container from Bluemix and run it on a local laptop that's running the Docker service as well. When I look at how Docker works, I start off with a Docker file. This contains the instructions on how to build the container. It pulls from a repository. I can include files, I can include commands to run. It then generates an image, which is then stored in an image repository. On Bluemix, we have a Bluemix repository, but there is also a public Docker repository. When I want to run a container, I instruct the Docker infrastructure to run a container. It will go and get that container from the repository. It will then put it into a Linux kernel container and then run that container. So this is a sample Docker file. You can see I start off with a base Ubuntu image. I then add some files and then run some commands. I explicitly tell it what port needs to be opened to allow traffic through, and then what command to run when the container is started. So in summary, containers and virtual machines allow you to bring applications into Bluemix. They provide a way to virtualize and partition an existing physical infrastructure. They allow you to converge the infrastructure as a service and platform as a service, and allow them to be co-located within the Bluemix platform. They also support large-scale deployments with very low latency, and they do provide that portability across environments.